Hello everyone, I am Dr. Velamani P.S., Professor, Department of Computer Science, University of Science and Technology, Meghalaya. Today we are going to see the theoretical network model continuation, the concepts related to Ethernet, fiber distributed data interface, and network scalability. Ethernet. So the Ethernet is a networking system that includes the protocol, port, cable, which will make the LAN for speedy data transmission via coaxial cable or fiber optic cables. It transmits data using two components, which is known as packets and frames. The following are the processed steps in data transmission. Step number one, MAC will maintain the physical addresses of the sender and receiver during the entire data transmission. Step number two, error correction of data for identifying transmission faults that can be followed. Step three, virtual LAN to maintain the quality of service of data transmission. Step number four, each frame is encapsulated in packets that comprise many bytes of data to set up the network connection. So these are all the steps involved in Ethernet communication. Component of an Ethernet connection. Ethernet protocol. It is a series of standards by IEEE standard which governs how the data is transferred in sender and receiver. Then the Ethernet port. The Ethernet ports are commonly known as jacks or jackets. So it is an opening on computer network infrastructure into which one may plug in Ethernet cables. It supports cable with a small plastic plug called RJ45 connectors, registered jackets. So with that plug, LAN cables will be connected and we can just plug in this particular Ethernet connector in the NIC. The Ethernet connector is used to connect to the equipment to a wired connection. And the Ethernet ports of a computer is linked to an Ethernet network adapter which is mounted with the motherboard. So while studying the network interface card, we have studied about the LAN cable connector, that is this RJ connectors that will be connected with the network interface card. Then the network interface card will be connected to the processor and memory of a computer. Then the Ethernet network adapter. An Ethernet adapter is a chip or card that fits into a slot on a motherboard and allows a computer to connect to a LAN. It is formally network interface card. So Ethernet cable is known as a network cable which is used to link the computer to a modem, router or switch. So these are all the components of the Ethernet. Now fiber distributed data interface. So the fiber distributed data interface, how this can be handled out, we'll see to it. And before that, some of the features of this fiber distributed data interface. It is actually token ring based protocol. It supports transmission rates up to 200 Mbps, megabits per second, supports 1000 nodes in LAN or WAN connections. So 1000 systems can be connected. So two types are there in this. Number one is single mode, that is laser light. Number two, LED light mode. Two light modes are there in this fiber distributed data interface. A single mode, that is the laser light. So in this laser light yellow, the cladding, coating, jacket, these are all the cover of the layer level of this particular single laser mode light. So laser, generally the light speed in vacuum tube, that is 3 lakhs kilometer per hour, that is 3 into 10 to the power 8 meter per second. So in case of this laser light yellow, if it is moving in this particular line, it will be traveled like this fashion, cladding fashion. It will move and it will be reflected, and it will be reflected, and it will travel towards to the path. Then coating, it is used to avoid the electrical signals or some other noise signals disturbance which is going to interrupt this laser light beams. Then this outside jacket is the gentle plastic cover which is over covering this entire unit of the cable. So the LED light mode is the multi LED light or orange light. Then the same thing will be the two beams will be sending like this. It will be traveled in such a fashion by using different protocols. The same cladding and coating will be there here in this pattern. So finally, the last topic is in this presentation, that is network scalability. The number of nodes, how this can be handled in the networking. In network scalability, the design pattern, the network design pattern is explained in various levels. The internet is going to be connected with the end user level. So how this can be connected? By using various routers. The router level this is. Then the core layer level, which may be a router. Then the distribution level layer level, which may be another set of routers or switches. Then the access layer level, which we can have the distribution level to the various nodes. 3 nodes here, again 2 nodes here, again 3 nodes here. So at this moment, in case of R1, R2, two routers are interconnected with each other, and it is having the capability to access the internet connections at the same time. For example, internet from the internet R1, R2 also having the capable to access the one internet server, and another internet server, same R1, R2 will access same R1, R2 will access the services at the same time by a service provider. And this in core layer level, this particular router or switches, it can have the parallel connection to communicate with each other, to access or share the information, to distribute in the distribution layer level. So from the distribution layer level, it can distribute to the various systems. So the network designs based upon this number of router and the number of nodes, the design pattern will be determined in any kind of enterprises. So in terms of explanation, the scalability is the ability of the network that can work with different application storage databases, and which can deal with the amount of users and nodes. So different applications, storages, databases, and deal with the amount of users and nodes. So different number of number of users and more number of users and nodes, more number of nodes will be used, different application storages databases at the same time. So to continue the proper functionality of the network, the size or volume must meet the higher side of the business to meet the demands of the business. When the situation, the hierarchical network for a business must contain the following, uh, which can be the situation like to support the critical application, to control network traffic, to support business needs, and the centralized administration. So, at this type of hierarchical network, the business must contain the following areas. The hierarchical network design is divided into functionality into three distinct layers, which we have seen already. Core layer, high speed backbone layer between networks. Distribution, it is used to forward traffic from one line to another line. Access layer, it is used to connect with the end user terminal. This is the specific functionality and focused terms of explanation at this moment. Designing for network scalability. So use expandable modular equipment or grouping of devices. That is, grouping is called cluster. Then the second thing is include design modules which can be added or upgraded and modified without affecting the design, without affecting the existing design. Then the third thing is this creating hierarchical addressing scheme which is going to deal with the IPv4 or IPv6 for more number of nodes which is going to deal IPv6 and that is 128 and IPv4 that is 32 bit, like that it will be handled internet protocol version 4. Use of routers or multi-layered switches to limit broadcasting of the signal from the internet to end user level. So that is the another designing method. The multi-layer level, we are using the routers and we are connecting these routers also parallelly. So the types of network scalability, number one is vertical scalability, number two is horizontal scalability. The vertical scalability, it increases the capacity of the hardware or software by adding to a physical system vertically. It will actually what it will do, it will increase the scaling of the storage, adding more devices with the existing system whenever there is a requirement. Horizontal scalability, it connects multiple network devices in order to work a single logic unit. So we have seen that two internet servers and two routers interconnected with each other, and those connections also we have seen in that figure. Scale out storage, which means adding devices in the connected of form in the form of cluster groups. The cluster groups forms which we are trying to connect to make the horizontal scalability. Then finally, the configuration of the devices in horizontal scaling is made up to improve the performance of the networks, which means to increase I/O bandwidth. So the maximum information or the maximum level of data needs to be transferred or shared among the various clients from the internet or various file servers, that can be done by using this horizontal scalability. Thank you very much. So in this video, we have seen the Ethernet and it communications, and in continuation to this, we have seen that FDDI, fiber distributed optic fiber cables. In continuation to this, finally we have seen the model which is used in various techniques and all. The point, network scalability. The network scalability, which comprises the vertical scaling as well as horizontal scaling. Thank you very much. Thank you.